running, including all drivers and power management. Once that is done, all that code will go mainline. I'll make sure about that. Obviously, we need free software backend to talk to the Neptune LTE, so you can actually make calls and so on. I can show you dumps on how it looks like when incoming calls are received and how to parse the incoming caller number and so on and so on. But obviously, there's still a lot of work to do in order to use the phone part of the phone from your own applications. USB on the go should be working. The PXA270 has support for it, and the way it is connected to the USB port should also support it, but it is not, it's not officially supported, and I haven't tested it so far. Yeah, we need to discover how the DSP log and other interfaces work because they sound so exciting. They even have very interesting stuff in there for debugging. So there's a module which is called APlog, and it basically has an LD preload library. So all the executors that are started are LD preloaded with a special library that redirects all prints to standard out and standard error over the USB link to the notebook to the development system. So any kind of applications that talk to standard out will then redirect it over USB, and you get that information on your host PC and all kinds of interesting features, all undocumented and so on. Native IPsec, a SCUM VM port is obviously an interesting thing to do because it's exactly the right resolution and it has a touch-sensitive screen, so it's ideal for running, Monkey Island and stuff. Obviously, we need to merge with Open Embedded at some point and get support, but yeah, that's some point next year. Okay, that's my usual thanks slide. I'm going to show 2 more special slides before I'm going to open a terminal window and we can actually see how the phone looks like, how you can access it, and so on. So now the 2 special slides which somehow have managed their way to me. So the power distribution, for example. This is just distribution of different power inside the phone, and it's a power distribution tree, basically, all the different voltages and where they go and so on. So this is just power. And obviously, for power management, you need to know when to switch off which and where and which individual part. And there's also, if you want to get a full picture, some overview schematic. So this is a phone, I'm still amazed by it. Yeah, so anyway, looking at the phone and logging into the phone. I've now connected it, switched into the USB network mode. I can telnet onto the phone. Is that visible? Yeah, it is. The font, can you read it? Yeah, I guess so. It's not even a root password. This is I didn't remove it. There was none. Okay, so we can do. For example, look at what kind of CPU it is, Xscale, and so on. I have obviously installed all kinds of additional software, so I'm just going to run a bash 2 and so I get tab completion and so on. Just give me a second. Okay. So if we look at list of processes on a mobile phone these days. No, that's just the first. I'm going to scroll about this page-wise. This is page 1, page 2, page 3, page 4, page 6. So we have a multi-threaded sound manager with 6 threads. We have, let me see, the database daemon, yes. Here is the database daemon. So this is 20.6 megabytes virtual size database daemon. So what they do is they run for your contacts and addresses and so on. There is a database daemon that stores in Berkeley DB on the flash file system. And that database daemon uses Unix domain sockets to talk to the front-end applications. It's just like everybody would design a mobile phone these days. And there's stuff like, now let me see, the address book and so on. So anyway, this is an idle phone. Apart from the telnet daemon, it's not running anything that it wouldn't run otherwise. And if we look at, do I have top now? Yes. If we look at this, it's like 45 out of 46 megabytes are being used in an idle phone. Doesn't do anything. And now imagine you start the GPS navigation application, and no wonder it always complains that it has too little RAM. But yeah, well, you know, glibc, and you need, obviously, anyway, a full-blown system. Yeah, just some demonstration. So I've already mapped all the key layout and so on. So I have LSOF, for example, in order to see, let's see if somebody has OpenDev vibrator at the moment. No, obviously not, but anyway. Oh, for example, well, maybe I can make it audible. Yeah. So it's just a Linux system. It has DevDSP, you can echo stuff to it, and it will come out of the speaker. Anyway, yeah, well, I'm not going to go any further from this point because there's still a short presentation on the Blue Angel phone. I'm just looking for the speaker. Where is he? Oh, there he is, yeah. Well, maybe this is the time to come up to the stage and give some insight onto another Linux-based mobile phone that is available these days. Yeah, so please welcome Smurf for his presentation on the HTC Blue Angel phone. Ich hoffe, du hast noch genug Zeit.
Ich denke schon. Oh, oh. Ja.
Kriegst du kein Bild?
Schauen wir mal die Auflösung runtersetzen. Oh, oh. Mist.
Versucht, glaube ich, die Auflösung umzustellen.
Ich mach mal schwarz, fertig.
Okay. Kannst du irgendwie so 1024 oder was machen?
Ja, das war es gerade. Kleinen Moment.
Maybe if there meanwhile are questions for the EasyX phone, we can answer to 1 or 2 questions while we get the notebook running with the projector. Any questions? Please use the microphones. Okay, I'm going to go over to this microphone, but anyway.
So there's a USB packet stream between the Linux processor and the GSM processor.
Yes, that's correct.
Have you been able to sniff and or migrate that to a real machine?
Well, I didn't migrate it to a real machine, but sniffing is not a problem at all. As I indicated, there are even special callback hooks in the USB host driver that you can attach to. So you can write a small kernel module. Do I have another USB cable here? But anyway, no, they're busy with the screen. I cannot show it here. But anyway, there's 2 exported global symbols, which is callback functions that void callback functions. So they don't interact with the USB traffic at all. You can just register to them, and you will get called for every USB packet that is sent or received on that channel. And I've written a small module that just print case hex dumps of that. And I've collected a number of hex stamps, and as I said, I've already indicated how to extract information on the number of incoming, the calling number of incoming calls and stuff like that.
Is the codec run on the audio codec run on the GSM processor? Or is it run under Linux?
It's run on the GSM processor, but you can configure. Basically, audio routing is again another very complex thing in that system. But you can transmit audio from the Linux to the GSM part. So, but in the default configuration, the codec runs on the GSM part.
Cool.
So the way how this works is actually that the audio is digitized in the PCAP, which is the support chip, and then it is there's a serial interface which interconnects both the application processor and the baseband processor and this support processor. And the GSM processor doesn't really care where it comes from because it's just serial interface. So you can also send audio data from the application processor. Oh, by the way, the phone actually has a SIP daemon installed. It's just not activated. So it ships with SIP support, including video SIP support.
What would you think that it needs as effort to support cryptographed telephone calls, so that you encrypt the air interface of the GSM because GSM is breakable, so you want to have some crypto to back your very important calls to your secretary or to your girlfriend. And how much effort would it be? What do you think?
It's certainly doable. If you just want to go for that, you can run the existing kernel. I'm sure you can manage these modifications, to do these modifications that are required without having to change too much of the system. But if you think about security, then you want to replace all the stuff that's on the phone. You want to run your own kernel. You don't want to run all the applications and the complex stuff that's running there. So you just want a very lean system. But to getting back to the original question, I don't think it's extremely difficult to do encryption for that.
Can you tap the audio? Because it could be that the audio is connected to the DSP in the GSM part, and so you could not tap it.
Well, if you want to do crypto over GSM, it's my understanding that you would want to make a data call anyway, because, yes, you cannot tap directly into the audio, but you can digitize the audio. So the audio is received by both the AP and the BP. And also you can send from any of these. So as I said, there's this serial interconnection between the 3 chips, which you can use to pass audio back and forth.
Okay, so because you would want to intercept it, because if you make a data call, you are evil, because they can see that you're making a data call. And so if you make a voice call and that is encrypted, there you hear some noise. Okay, they are at a river or somewhere.
I don't think you can do it in the GSM. I don't think you can make encrypted voice calls using voice calls, because as I said, the audio is there's uncompressed PCM audio going into the GSM chip, and then it gets compressed using the, what is it, AMR codec and sent over the wire. So you cannot encrypt first and then put it into an audio compression codec. It wouldn't work.
Okay.
So the only chance to do it is make a data call and basically put the phone into voice recorder mode and record. Get the PCM audio into the Linux PXA processor and do whatever kind of software codec on there, and then put it into GSM, into GPRS or GSM data frames and transmit them.
Okay.
Hello? Hello?
Yes, I think we still have problems with Nord. Yeah, question, yes, please.
Is there an easy way to edit the flash file systems? Because I have to change a little bit.
Yes, there is no easy way to change the flash file system, because they are, most of the partitions, especially the root file system, they are on read-only flash file systems, so you cannot modify them on the fly. So you need to make a copy on the PC, do whatever changes you want, and then transfer them back to the device, and then write them, for example, into def-mtd, whatever.
But this is possible.
This is possible, yes.
Without special tools?
Well, with freely available free software tools that we have now in the OpenEasyX project, yes.
Okay. Nice.
Because, the main issue is that the memory management unit of the application processor is configured in a way to protect accidental